We've got a sequence here, and it wants us to work out the next term. Now, this is a non-calculator question, and this sequence looks horrendous. And the first thing I notice is that it's not like it's getting pretty big fast. It's not. So it's not. I'm not adding a term on every time. That's basically what I'm trying to say. And what I'm actually doing is I'm multiplying by something. So let's just test this little theory. So here it looks like I'm multiplying by root 7. And then if I was to then multiply by root 7 again, well, root 7 times root 7 is 7, and I would indeed get 14. So my little hypothesis seems to be working, and then it works again here. So basically, this is called a geometric sequence. And this rate, we call it, what do we call it? We'll call it R sometimes, but it's the multiplicating thing. And in this case it's root 7. So how are we going to work out the next term? Well, it's going to be 14 root 7 multiplied by root 7, which is going to be 14 times 7, which is 98. Okay, the next one, the harder one, is find the nth term. So you need to know that basically for expressions like this, like when you're multiplying it, if I was going to multiply by 2 every time, starting with 2, 4, 8, then this would be 2 to the power of n, because it's 2 to the power 1, 2 to the power 2, 2 to the power 3. If I was to do, however, 1, 2, 4, 8, then I don't have 2 there, but I'm still going up in powers of 2. So I want 2 to the power n, kind of, but I want to kind of shift it back a bit. And what I have to do is 2 to the power of n minus 1, because then then this just becomes 1 at the very start. And that basically is what I'm going to use to find the answer. So in this case, it's like I've got root 7 to the power n, except I've sort of shifted it back. So what I have is root 7, but it's to the power of n minus 1, because that would give me 1, but when n is 1, I'd get root 7 to the power 0, then I'd get root 7, then I'd get 7, then I'd get 7 root 7, and so on. And this is nearly what we have, except I've got a 2 in there instead. So just to finish it off, I need to multiply by 2. I've tried to take my time there and explain where that nth term comes from. That is the answer. There is a formula for this kind of sequence, and it's un, that's the nth term, is the first term times my common ratio, we call it, to the power of n minus 1. That will always work, in fact. I've done that quite quickly, but a, in this case, is 2. R is this common ratio, root 7, and it does work, and it will always work for a geometric sequence. Find the value of the 21st term divided by the 17th term. Well, how many times have I multiplied by, so this, I think maybe the easiest thing to do is the 17th, 18th, 19th, 20th, and 21st. Whatever this is, let's call it x. Then this one is going to be root 7x. This one is going to be 7x. This one's going to be 7 root 7x, and then finally I'm going to get 7 times 7x is 49x. And therefore, if I do 49x divided by x, I'm going to get 49. I've done this algebraically. You might, and the other way you could do it is just think, right, I'm multiplying by root 7 4 times. Okay, to go from 17 to 21, so that's why it's going to be 49 as if one divided by the other one.